Welcome everyone. So in this video we will study about acceleration. Okay. So far we have studied topics like distance, displacement, velocity, speed. Now moving on, we will study about acceleration. So what is acceleration? So you can define acceleration as rate at which an object changes its velocity. Now, I would like you to revise what we have learned about velocity. So, velocity was what? Rate at uh, which an object, okay, changes its position. Okay. Now, so this change in position was what? This was displacement. Okay. So this change in position was displacement. So velocity is basically displacement. If I want to speak in high level, velocity is displacement upon time. So that was velocity. Okay. Now in this definition, what we are learning is change in velocity is rate at which the velocity is changing is time. So acceleration is basically change in velocity upon time. So you might see a kind of a pattern here, like acceleration is based on velocity, velocity is based on displacement. So that's the point I want to bring it here. Just think about like everything is connected, right? Now, in a minute we will see what's the need of defining acceleration. Okay. Now, by this definition of acceleration, we can easily calculate the SI unit. We know velocity SI unit is what? Meter per second, we have seen previously, and the time is second, right? So the SI unit of acceleration is meter per second square, which is here. And the third point I would like to mention is, since acceleration is based on velocity, which is a vector quantity, so acceleration is also vector quantity. And we know what that means. That means in order to completely define acceleration, we have to provide both magnitude and direction. So both magnitude and direction needs to be provided to completely define acceleration quantity for an object. Okay. Now let's see an example which combines all these points together. So imagine we have a car whose velocity is changing with time. So at point A, when time is 0 seconds, so that's our reference point. So that's where we are starting to look at. Our car is at 0 meter per second. So it's kind of stationary. So car is at rest. After 1 second, we see the velocity of the car is 20 meter per second. The reason I'm saying velocity is because I see it is plus 20 meter per second. And so if I ask you what is the acceleration as the car is going from point A to point B, so acceleration is generally denoted by letter A. So we know acceleration is change in velocity. So change in velocity is what? 20 meter per second minus 0, so which is going to be 20. And then upon time, so 1. So acceleration is basically 20 meter per second square. And one thing we want to mention is the direction. So direction is positive. Why it is positive? Because plus 20 minus 0 is going to be plus 20. Okay, remember that. Let's move on. Let's look at the second one. As a car is moving from point B to point C, what is the acceleration? So acceleration is pretty plus 30 meter per second minus 20 meter per second upon 1 second, because it's been 1 second. So and this value is going to be, again, it's going to be 10 plus 10 meter per second square. So direction between A and B and C is same, that is positive, but the magnitude of acceleration has gone down. Okay. Now between C and D, let's calculate acceleration. So between C and D, the acceleration is, so final velocity, which is plus 10, minus initial velocity is minus 30, and then divided by time, which is 1. So this is going to be minus 20 meter per second square. So what we are seeing is, even though car is traveling in the same direction, it's always traveling in from left to right, right? In all that point, the direction of acceleration is changing. Initially it was positive here, here, but now it is negative. So it is possible to have acceleration negative even though your direction of the velocity or direction of the motion is positive. So let's do the last exercise here. When the car is going from D to E, your acceleration is plus 20 minus 10 by 1 second, which is going to be 10 meter per second square in the positive direction. Okay, so just remember this: a velocity direction and acceleration direction can be different. Now the unit of acceleration is meter per second square, and you can easily calculate acceleration by change in velocity upon time. Let's see what's meant by constant acceleration. Okay, what is the motion like when an object is traveling with constant acceleration? We know velocity and acceleration are connected. So acceleration is change in velocity upon time. Okay, so when we say constant acceleration, I'm saying the velocity is changing by same amount. So velocity is changing by a constant amount each second. It does not mean constant is acceleration is zero. Okay, velocity is changing, so constant acceleration is not equal to constant velocity. Okay, if the velocity is constant, then your acceleration would be zero, right? Because acceleration is change in velocity. So constant acceleration is different than constant velocity, because constant velocity means acceleration equal to zero. Okay, now in this example we see the object is traveling from point A to B to C to D and E. So let's calculate the acceleration in each of these intervals. So between A and B, the acceleration is 10 plus 10 minus 0 divided by 1, right? In B to C, acceleration is plus, in between B to C, the acceleration is plus 20 minus 10 divided by 1. C to D, plus 30 minus 20 divided by 1 second, right? 1 second here. And then D to E is plus 40 minus 30 divided by 1. So if I want to write here, between a car is going from A to B, acceleration is 10 plus 10. B to C is plus 10 again. C to D is plus 10 again, and D to E is plus 10. So as you can see, the acceleration is not changing even though velocity is changing. Okay, so this is an example of a constant acceleration. Okay, so means if the velocity is changing by constant amount each second, you will say the acceleration is constant. And okay, so let's look at more here. We have seen previously that acceleration and velocity can have different direction. Let's look at an example and then try to understand it more. 2 points here. So if the speed of an object is increasing, so if an object is speeding up, then acceleration and the velocity is going to be in the same direction, or the object is slowing down. Okay, then the acceleration and the velocity would be in opposite direction. Let's look at an example here, right? So in between A to B, your velocity is positive because it's going in the same direction. Here the velocity is positive and acceleration. So in this, as you can see, the velocity of an object is going up, right? So it's going from 0 to 20, so object is speeding up. Then based on this statement, the acceleration should be in the same direction, and you can calculate it. So A to B, acceleration is what? Plus 20, which is the final velocity, minus initial velocity, which is minus plus 0, right? And then change in time is 1, so it's going to be 20 in the positive direction, meter per second square. So acceleration is in positive direction. Between B and C, velocity is positive because car is still traveling in the same direction. Our object, which is car here, is speeding up because initial velocity is lower than the final velocity, and that's why your acceleration should be positive, right? Again, you can calculate by a formula, but it would be positive here. Between C to D, your velocity would be positive because car is still traveling in the same direction, but your velocity is decreasing. Initially it was 30, it became 10. So based on this statement, it should be negative. Acceleration should be opposite of the velocity, and let's calculate it. So let me erase this one. So we are looking at between C to D. Acceleration is final velocity, which is plus 10, minus initial velocity, which is plus 30, and then divided by time taken, which is 1 second. So this is going to be minus 20 meter per second square. So the velocity and acceleration is in opposite direction, right? Similarly, between D to E, your velocity is positive because car is still moving in the same direction, and acceleration would be negative because your velocity is decreasing. It was 10 before, now it is 5. Okay, so I hope this point is clear that acceleration and velocity can be different. So typically, if an object is speeding up, then the direction of the motion or the velocity would be same as the direction of acceleration, and if the object is slowing down, then acceleration would be in opposite direction. So now I want to give you another point here that I see many of the students have a confusion between negative acceleration and decreasing acceleration. So what's the difference between the two? Are the two the same thing or not? And we will cover this by an exercise. Imagine that your car is at rest. Okay, so at time equal to 0, you are at point A, so velocity of the car is 0. Now in this table, it's given that after 1 second, the velocity of the car become 10. After 2, it become 20. After 3, it become 10. 4 is finally car comes back to its rest. Okay, so now let's calculate the acceleration. So let's say this was 1 second, 2 second, 3 second, and then 4 seconds. So between A and this 1 second point, the acceleration we know is final velocity minus initial velocity by 1 second. So if you do the calculation there, it's going to be plus 10. Similarly, if I want to do it here, it would be plus 10 because the difference between the two is 10. It would be minus 10 here, and this would be minus 10 here because the velocity is, even though velocity is positive, but it is slowing down. So this table which we have just filled, so this table which we have just filled, you can see the acceleration is constant. The value of the acceleration, the magnitude of the acceleration is constant, but direction is changing. Initially it was positive, then it becomes negative. So this type of motion we will call negative acceleration. Okay, so this is a negative acceleration. Now let's look at this second example. So in the second example, if we do the same exercise, in the 1 second it was 10 meter per second, second it was 20. So if I want to calculate the acceleration between t equal to 0 second and 1 second, it would be 10 here in the positive direction. This would be another positive 10 because 20 minus 10 is 10 and time taken is 1 second. Here it would be plus 5. Here it would be plus 2. Now, one thing here we can look at is that acceleration direction is positive throughout the motion. It's not negative, it's not. So object is always speeding up. As you can see, the velocity is always going up, right? um, but the value of the acceleration is it's decreasing. Initially it was 10 the magnitude, now it is 5, then becomes 2. So this type of motion where the acceleration is positive but or is in the same direction but the velocity magnitude is decreasing is mostly a decreasing acceleration example. Let's say I want to plot this on a time versus velocity graph. The velocity is always increasing. The slope might be decreasing over time, that's why acceleration is decreasing in this example, but velocity is always increasing. In this example, if I want to plot it, then your velocity and time graph would be a little different. So initially velocity was up, right? It was increasing 10, 20. Initially it was 0 when it started increasing, and then it starts going down, becomes 0 final, right? So this is initial, this is final. So even though velocity, because if this is positive, this is negative, the velocity is always positive in this whole motion, but since there is a change in slope here, the acceleration is negative, and we will talk about these graphs in more detail later on. So I have few practice questions for you guys. I have this table here. Try to fill it up. I think it will give you a better understanding of how to calculate acceleration, will give you more understanding of this direction of acceleration and how does it compare to with respect to velocity, direction, what does the speeding of motion and reduction in speed means, and why the acceleration direction is positive or negative.